The rapid progress of AI is fueling demand for ever more powerful computing. Meeting this demand requires chips that are not only more numerous, but also faster and more energy efficient. At the heart of this challenge lies the need to reduce electrical resistance between the miles of copper interconnects and the billions of transistors. In advanced chip designs, these tiny metal contacts that link each transistor to the wiring network are just a few nanometers wide and can contribute significantly to the chip's total resistance, creating a bottleneck to performance and energy efficiency. At these nanoscale dimensions, traditional materials are heavily impacted by shrinking dimensions, increasing electrical resistance. Applied Materials' Centris Spectral Molybdenum ALD system fills chip contacts with molybdenum, a metal which can be made thinner while preserving efficient electron flow. This innovation reduces critical contact resistance by 15% beyond the industry benchmark Selective Tungsten from Applied, boosting overall chip performance and energy efficiency. With the Centris Spectral Molybdenum ALD system, Applied Materials empowers chipmakers to realize the next generation of AI by unlocking the potential of smaller, faster, more energy-efficient chips.